Hi everyone, welcome to the Earth Science Regions Review podcast series created by the Hommocks Middle School Earth Science Department. Today we're going to be talking about page 11 in the reference table, the P-wave and S-wave chart. Before we get started, there are some terms that you need to know. You have travel time, which is the amount of time it takes a P-wave or S-wave to travel a specific distance from the epicenter. You have your arrival time, which is the time that the P-wave or S-wave gets to you or your seismic station. Your origin time is the time the earthquake starts. Lag time is the difference in arrival times. Epicenter distance is how far you are from the epicenter of the earthquake. And epicenter location is exactly where the earthquake started, the exact geographic location or region. Now, once you have those down, you can use your chart to help manipulate questions. So the first thing you need to understand are your axes. The vertical axis is your travel time. That's in minutes. It goes from 0 to 24 minutes. Each line is an increase of 20 seconds. Your horizontal axis is your epicenter distance. That goes from 0 to 10,000 kilometers. Each line increases by 200 kilometers. Very important to keep your P wave and S wave curve straight. You notice that the closer together they are, the smaller the lag time. The farther apart they get, the bigger the lag time, and the farther away those waves are going to be from the epicenter. So what happens here is you have to understand that P waves travel faster than S waves. So the faster the P wave travels, again, the farther it's going to travel, the bigger the gap you're going to get between your P wave arrival and S wave arrival. So here's just a couple examples on how to use this chart. What I like to do is I like to tell all my kids to identify keywords like travel time, arrival time, origin time, and try to figure out what is given to you that you can get directly off the chart. So for instance, S-wave travel time is 4 minutes. How far does it travel in this time? So your keyword there is going to be your travel time. Okay, so they actually give you a 4-minute travel time. So you find the travel time of 4 minutes. We want to know how far did it travel in that time. So you follow it over to your S-wave, you follow it down. It turns out to be about 1,000 kilometers. Okay? So those are some of your basic problems like that. Let me show you another one. How long does it take a P wave to travel 5,000 kilometers? Again, look for keywords. Okay? For instance, travel is going to be an important term here. We want to know the travel time for a specific distance. 5,000 kilometers is given to you. So you find 5,000 kilometers. This time you bring it up to your P wave curve. You follow it across. You tell me the travel time for that, and that's going to end up being about 8 minutes and 20 seconds. So you can very simply determine the epicenter distance or the travel time based upon the information given to you. Very, very basic problems. You can also get problems like this. How far does an S wave travel in 16 minutes? So again, you want to look for keywords. Okay, you want to look for not only keywords but also information given to you. Okay, 16 minutes is given to you. Follow it over to your S wave. You follow it down to tell me your distance. So it would take your S wave in this case 16 minutes to travel 5,400 kilometers. So very, very important to identify the information given to you that you can manipulate right from your chart. Here's a little bit more involved problem. An earthquake P wave travels 8,000 kilometers and arrives at a seismic station at 11:40 a.m. That's 11:40 in the morning, 11 hours and 40 minutes. We want to know the origin time. So some key words you might want to highlight. Travels, arrives, and origin time. So very important to keep a lot of these terms straight. So what is given to you that you can use right off your chart? 8,000 kilometers. So you find 8,000. They're talking about the P wave. You bring it up to the P wave, you follow it across. Turns out to be about 11 minutes. If the P wave arrived at 11:40, but it took 11 minutes to travel the 8,000 kilometers, what you're going to do here is you're going to take the 11 hours and 40 minutes, and from that you are going to subtract the 11-minute lag time. If you subtract them properly, you should come up with an origin time of 11:29. Earthquake starts at 11:29 a.m., 11-minute travel time to get to you. The P wave arrives at 11:40 to you, which is 11 minutes later. And through that course of that, Okay, it would have traveled 8,000 kilometers. You have an earthquake. It arrives at you 12 o'clock p.m., okay, which is going to be 12 in the afternoon. It's going to be around lunchtime, okay? But during that time, it travels 6,000 kilometers. We want to know what time will the S wave arrive. So again, you want to look for keywords like arrives, okay, and travels. So determine what is given to you right from the statement that you can find in your reference table. So you find 6,000, you follow it straight up to your P wave. P wave is going to take 9 minutes and about 20 seconds to travel 6,000 kilometers. Your S wave is going to take 17 minutes to travel 6,000 kilometers. What you do with those times is you subtract them. And once you subtract them, you will get a difference of 7 minutes and 40 seconds. Okay, if the P wave arrives at 12 p.m., the S wave is going to come in at 7 minutes and 40 seconds later, so it's going to arrive at 12:07:40. Probably the most common type of question going to be asked is going to be your typical seismogram that's going to give you arrival time of the P wave and arrival time of the S wave. Very important to remember how to subtract time. This way you're going to get your lag time. Once you determine your lag time, you will do the wedgie method, in which you're going to take your piece of paper, okay, you're going to mark it off. On the vertical axis, you will mark off your lag time of 2 minutes and 20 seconds. You then take that piece of paper and you slide it in between your P wave and S wave curve. Once you slide it in between the P wave and S wave curve, what will happen here is where the top mark touches the S wave and the bottom mark touches the P wave, you can determine your epicenter distance. So I hope this was a quick tutorial to kind of show you some of the examples that we're going to use on your page 11 P wave and S wave chart. Thanks so much. Bye.